Okay, students, welcome to the new session. So, in this session, we will discuss what we did in the last few lectures or in the last session. In the last session, we discussed about derivatives and the process or the methods to find out the derivatives of the various functions. Now, in this session, we will actually discuss the various applications of the derivatives. As far as applications of the derivatives are concerned, a wide area where derivatives are very frequently used, but we will restrict ourselves up to some restricted areas. For example, among those areas, we will discuss the applications of the derivatives to find out the maximum and minimum value of a function, and then further we will extend the same idea for the marginal analysis. So before proceeding this session I am calling it because session is a combination of 4 or 5 lectures. So you may call it as a session or a lecture. In this session, what we will discuss how we will find out the maximum and minimum value of a function using first derivative. Then we will also find out the maximum and minimum value of any function using the second derivative. This is case 1. And subsequently, the marginal analysis means what? Actually, there are 3 basic functions which are very frequently used in the area of business or commerce. They are the cost function, revenue function, and profit function. So we will see how these 3 functions are being optimized using the concept of differentiation. Optimize means we can either maximize or minimize. For example, if we are talking about the cost, the natural tendency of every human being is what he or she always try to minimize the cost. On the other hand, if we are talking about the revenue and profit, these 2 functions are always being maximized. So this is a brief summary of this session that we will cover in all the lectures or in complete session, right? So let us start first to find out the maximum and minimum value of a function. Actually, the maximum and minimum value, it's a very key role or prominent role in our day-to-day life. If we are going to purchase, for example, a pen or any book at a shop, so what happens there? We as a customer try to minimize the price of the pen or book, and the shopkeeper at the same time try to maximize the price of the pen or book. So these 2 concepts, maxima and minima, they generally runs like a track of a railway, but they never meet, right? So first, in first case, we will discuss how we can find out the maxima or maximum value, minima and minimum value. So before proceeding, let us understand the difference between maxima and maximum value. Maxima means what? A point at which the function will attain its maximum value. So maxima means a point, likewise minima means a point. For example, if you are throwing a ball into the air, what will happen? The ball will go up and it will attain a point at which it will stop. Then it will start coming down. So the point at which it will stop, that is the point of maxima. So at that point, if you calculate the height from the ground, the height will be maximum. So maxima means a point at which the function attains its maximum value, and minima means a point at which the function attains its minimum value. Let us define these 2 concepts. A function fx is said to have a maximum value fa. Fa is its maximum value. So if it is a maximum value, so naturally it will attain at a particular point, right? So a function fx is said to have a maximum value fa at a point x is equals to a if fx ceases to increase at x is equals to a and begins to decrease as x increases beyond a. So this is what? This is also a kind of relationship. So the function is said to have a maximum value at a point a. The value is called fa. After that, the value fa stops increasing, right? Whatever the value of x is increasing, right? It will stop the increasing. So the function fx is said to have a value fa at a point x is equals to a if fx ceases to increase at x is equals to a and begins to decrease as x increases. After a point, the function fx will start decreasing as x increasing. So the point from which the function starts decreasing is known as the point of maxima. For example, if I am drawing this graph, so this is a point, so the point, this is the maximum point. From this point, it comes down. So this is the point of maximum. Like this, if you move like this, the function is going up, it is attaining its minimum value. So here, after this, it starts increasing. So this is the point of minima. So this is known as the point of maxima and this is known as the point of minima. Similarly, a function fx is said to have a minimum value fa at a point a if fx ceases to decrease. This means after that point, fx will stop decreasing as x is equals to a and begins to increase as x increases beyond a, right? So to understand the concept of maxima and minima, you should understand only one. The second one you can automatically understand, right? So this is how we can define. This means what? If you want to find out the maxima of a function, always we get a point at which the function attains its maximum value. After that, it starts decreasing. The point will be known as the point of maxima. And a point at which the function decreases its maximum and after a point it starts increasing, that is known as the point of minima. So this is how we can define the concept of maxima and minima and then see how we can find out these maximum and minimum values of the various functions using the concept of derivatives. So in case 1, first we will find out the maxima and minima of any function using the first order derivative and then we will proceed the same process for using the concept of second derivative. So the method of finding maxima or minima. So this method runs as follows. See, for a given function fx, find its first derivative f dash x. What does it mean? The function is given to you, you want to find out its maxima or minima or maximum value or minimum value. First find out its first derivative, that is f dash x, and then put it equals to 0. So whenever you will put f dash x is equals to 0, it will be treated as an equation. And whenever you are having an equation, find out the solution of that equation. So the equation will give you the values of x, if equation is in terms of x, right? And how many values x will give you? It depends upon the highest power of x. You know from your 9th or 10th standard, if an equation is of order 2 or degree 2, it will have 2 factors or 2 roots, and if an equation is of order 5, it will have 5 roots or 5 factors. So if f dash x is equals to 0, this will give you certain values of x, right? X may give you 1 value if the highest power of x is 1. X will give you 2 values if the highest power of x is 2. X will give you 5 values if the highest power of x is 5. After that, what we will do, we will consider the sign of f dash x in the neighborhood of the stationary points. So the points what we will obtain by putting x is equals to 0, they are called stationary points. And from point 2, the values of x, right? The values of x are called stationary points, right? Stationary point. And after that, we will consider the sign of f dash x in the neighborhood of stationary points. Neighborhood is a very technical term. You can understand neighborhood in the way, say x is equals to 1, right? This is point 1. X is equals to 1. Neighborhood means very close area. This is our neighbor. So any value which is very close to 1 at its right hand side or at its left hand side is called a neighborhood, right? Say if I take x is equals to 1 is this point, for example. So if we draw a circle like this, this will be known as the neighborhood of 1. So we will consider the sign of the derivative in the neighborhood of the stationary point. If it changes from positive to negative, then fx has maximum value at that point, and if it changes from negative to positive, then fx has minimum value at that point. If f dash x does not change the sign, then we can't say anything about maxima or minima, and such a point is known as point of inflection. Clear? So as a brief, let me revise it. The function given to you whose maximum or minimum value you want to find out, first find out its first derivative, put it equals to 0, it will give you an equation. Solve this equation, this will give you some values of x. These values of x are called stationary points. After that, we will check the derivative of the function fx, that is f dash x, in the neighborhood of these values of x. Neighborhood means very close. So what happens if the sign changes from positive to negative? Then the function will have maximum value, and if f dash x changes sign from negative to positive, then it will have a minimum value at that point. And in case f dash x doesn't change any sign, then it is known as the point of inflection. Now let us take an example to understand the method. How does it work, right? Find the point of maxima and minima of a function fx is equals to x cube minus 3x square minus 9x, right? This is our function. So try to understand the concept so that a single example must be sufficient to understand the idea. So we have given a function this is our function. Fx is equals to x cube minus 3x square minus 9x. What is our first step? Find out its first derivative. So f dash x is what? 3x square minus 6x minus 9, right? For stationary points, what we did, we put it equals to 0, right? So f dash x is equals to 0. When you will put this is equals to 0, so this is an equation as I have told you, and this is an equation of degree 2, so it will have 2 roots. Solve this quadratic equation by known methods. You all have done all these at your earlier classes. If you will find out its solution, the solution will come at x is x plus 1 and x minus 3. They are the factors of these two equations, which gives the values of x. X is coming out to be 3 and minus 1, right? These are the two values. Since the highest power of x is 2, so x will give you two values. So these two values of x are called stationary points. So these two stationary points, and out of these two stationary points, you can have either maxima or you can have minima. What does it mean? And we can find out the maxima or minima only at stationary points. See, now we are checking first for x is equals to 3. See, x is equals to 3 means what I told you, see like this, x is equals to 3. In the neighborhood means we will take a value slightly less than 3. Less than 3 means 2.9 or 2.99 or 2.99. Very close to 3. Or slightly after 3, that is 3.1 or 3.01 or 3.001. So we will check the sign of the derivative at these two values, which are lying near x is equals to 3, either its left or its right. See what happens. If x is equals to 3 and x is less than 3, then what is the value of f dash x? See, let me show how does it work. What is the value of f dash x? F dash x is about to x plus 1 and x minus 3. What we are doing? We are taking the value of x slightly less than 3. So, see, if this is 3, to slightly less than 3, we are somewhere here, say we are taking 2.9. So, put the value of x here 2.9, what you will get? This is 2.9 plus 1, what you will get? That is 3.9 into, this will become negative, right? Because x is less than 3, so this bracket will give you the negative value. So, f dash x will become negative, right? So, in first case, if we are taking value very near to 3, before 3, then the sign of the derivative is negative. Now, what we will do? We will take any value of 3 that is after 3. So, this will be what? This will be something 3.1, for example, or 3.01. So, take what will happen here. F dash x is equals to x plus 1 and this is x minus 3. So, naturally, this is positive. If any value of x is greater than 3, then this bracket will also become positive. So, this is positive into this is positive, the product of these two is positive. So, what we are getting? In case 1, we are getting negative value and in case 2, we are getting positive value. So, f dash x changes sign from negative to positive in the neighborhood of x is equals to 3. Thus, f of x has a point of minima at x is equals to 3. Clear? Whenever the derivative changes sign from negative to positive, the point will be the point of minima. Now, the second position is what? X is equals to 1, right? Take this. If you take any value of x less than minus 1, so f dash x will be negative. And if any value of x is greater than 1, then f dash x will be negative. So, it is changing sign from positive to negative. See, in the same way, in this expression, take any value of x which is greater than minus 1 and take any value of x which is less than minus 1, you will get the f dash x is changing sign from positive to negative. So, f dash x changes sign from positive to negative in the neighborhood of x is equals to minus 1. Thus, fx has a point of maxima at a point x is equals to minus 1. So, x is equals to minus 1 is a point of maxima and x is equals to 3 is a point of minima. Now, we can calculate the maximum and minimum values. So, how we can find out the maximum and minimum values? The point at which we are getting the maxima, put this value in the given function, you will get the maximum value. And the point at which you are getting minimum value, put this value in the original function, you will get the minimum value. So, the maxima is attained at a point x is equals to minus 1. So, put x is equals to minus 1 in our original function this. You will get 5 as the maximum value and put x is equals to 3 in our original function, you will get minus 27 as minimum value, right? So, this is how we can find out the maximum and minimum value of any function using the method of first derivative with the help of the first derivative, right? Now, the stage 2 is what? As I have told you, we will find out the derivative of the function using the first derivative and then we will find out by second derivative. Second option is what? We can also find out the derivative, we can also find out the maximum and minimum value of any function using second derivative test. So, the second derivative test for maxima and minima, it runs almost in the same way. So, let me explain the process once again from the beginning. Second derivative test is what? You have given a function y is equals to fx, find out its first derivative, very simple, put it equals to 0, you will get an equation. Solve this equation, you will get certain values of x. These values of x will be known as stationary points, right? And these stationary points will give you the point of maxima or point of minima. Which point will give you the point of maxima and minima? For that, we will calculate the second derivative. Put the value of x in the second derivative. If second derivative is negative, that is less than 0, then the value of x will be known as the point of maxima. And put the value of x in the second derivative. If second derivative is coming out to be positive, then the value of x will be known as the point of minima, right? If the second derivative is negative at any point of x, for any value of x, the point will be known as the point of maxima. And if the second derivative is coming out to be positive for any value of x, that value of x will be known as the point of minima. But in some cases, the second derivative becomes 0 for any value of x. For example, if you are putting the value of x in the second derivative, and second derivative is also 0, then we say that that point is known as the point of inflection, right? Point of inflection means a point at which we can't say anything about maxima or minima. Then what we will do, we will calculate the third derivative, see here, f triple dash x, and put the value of x in the third derivative. It will be either 0 or non-zero. If it is not equals to 0, then this point is known as the point of inflection, and the function will attain neither maxima nor minima at this point. Okay? If the third derivative is not equals to 0 for any value of x, then that value of x is known as the point of inflection, and point of inflection is a point at which the function will attain neither maxima nor minima. Second option, if we put x is equals to a in the third derivative, if it becomes 0, then again we cannot say anything about maxima and minima. And then we will come to the fourth derivative. And we will use the same rule in fourth derivative as we used in second derivative. If the fourth derivative becomes negative for any value of x, then that value of x, the function will give you maxima. If the second derivative becomes positive for any value of x, then for that value of x, the function will give you the point of minima. So this way, this process will remain continuous, right? Let us take an example to understand the question completely. This example will show you all the three possibilities. Before proceeding the solution of this example, let me explain what we have done in this question. Actually, this is a question, what options we can have. If you have given any function, you can have a point of maxima, you can have a point of minimum, you can have a point of inflection, right? These are the three things. So let us see how these three things can be calculated simultaneously in a single example. I will try to explain all these things up to my best. See, for what value of x, the function this, x raised to the power 5 minus 5x4 plus 5x cubed minus 10 has maxima dash minima. Maxima dash minima means if it is having maxima, find out the maximum value. If it is having minima, find out the minimum value. This is case 1. For what values of x this function is having maxima dash minima. Case 2, prove that x is equals to 0, the function is neither maxima nor minima. I have also explained a point that is known as neither maxima nor minima. So be careful. Let us take the solution. See, we have given here y is equals to this, right? Y is equals to x raised to the power 5 minus 5x4 plus 3x square minus 10. The first step is what? Find out its first derivative, right? So the first derivative is this. dy over dx is coming out to be 5x4 minus 20x cubed plus 15x square, right? You can also calculate the second derivative here. This is your second derivative, that is d2y over dx2. It is coming out to be 20x cubed minus 60x square plus 30x, right? What is the basic condition for existence of maxima and minima? The first derivative should be equals to 0. So we will equate the first derivative as 0. For stationary points, see this, dy over dx is equals to 0. It means this equation 5x4 minus 20x cube plus 15x square is equals to 0. Right? Now solve this equation. Here the power of x is 4. You can take the power of x is 4. See this. You can take 5x square common. What is left? X minus 1 and x minus 3. Find out its factor. If you will take 5x square common, what is left? X square minus 4x plus 3. Find out its factor. Its factor will be x minus 1 and x minus 3. Right? See. So if we will put it equals to 0, the values of x are 0, 1 and 3. So these are the three stationary points for the given function. And these three stationary points will give you everything, whether the point of maxima, point of minima, or point of inflection, or neither maxima or nor minima. Let us check one by one. Let us see x is equals to 1, because in the second case, what is being asked, prove that x is equals to 0, the function is neither maxima nor minima. So the point 0 is excluded because you have to show that 0 is neither maxima nor minima. What is left? 1 and 3. So first we will check at the point 1. So to check whether the point 1 is a point of maxima or minima, we will find out the second derivative, that is d2y over dx2. And d2y over dx2 we have already calculated here earlier. This is the value of d2y over dx2. Now put here x is equals to 1 in this second derivative. So see, 20 into 1 minus 60 into 1 plus 30, you will get it as minus 10, and minus 10 is negative, that is less than 0. Hence x is equals to 1 is a point of maxima. Right? If the second derivative is coming out to be negative for any value of x, then that value of x is called the point of maxima. Now to find out the maximum value, as we did in the last example, x is equals to 1 is a point of maxima. So put simply x is equals to 1 in your original function, that is y is equals to x5 minus 5x4 plus 5x cube minus 10. So by putting x is equals to 1 in this, we will get the maximum value of the function is coming out to be minus 9. So x is equals to 1 gives you a point of maxima, and its maximum value is coming out to be minus 9. What is left? 3. Now check about the point x is equals to 3. Similarly, in the second derivative d2y over dx2, what we will do? We will put x is equals to 3. So this is our second derivative. So 20 into 3 raised to the power 3 minus 60 into 3 square plus 30 into 3. Simplify this, you are getting it as 90. And 90 is a positive number, means greater than 0. So this shows that x is equals to 3 is a point of minimum. Right? And the minimum value of the function is obtained by putting x is equals to 3 in our original function. So by putting x is equals to 3 in our original function, and after simplification, we will get minus 37 as its minimum value. Right? So overall, we were having three stationary points, 1, 0, 1 and 3. 1 is giving you point of maxima and 3 is giving you point of minimum. Right? What is left? In the second part of the question, you have been asked to prove that x is equals to 0. The function is neither maxima nor minima. Now this is left for the proof. For neither maxima nor minima, what happens? We have already discussed. So what we will do here, put x is equals to 0 in the second derivative now. Here, in the second derivative, put x is equals to 0. See what happens. The second derivative becomes identically 0. So nothing can be said about maxima and minima. So whenever the second derivative becomes 0 for any stationary value, we can't say anything about maxima and minima. So what we will do next? We will find out our third derivative, that is d cube y over dx cube, and put here x is equals to 0 and see what happens. D cube y over dx cube is coming out to be this 60x square minus 120x plus 30. Now put x is equals to 0 here. It is coming out to be non-zero. And you know, this is the requirement, this is the condition. If the third derivative is coming out to be non-zero for any stationary point, it shows that stationary point, the function will have neither maxima nor minima, right? So this is how we can find out the point of maxima and then maximum value, and the point of minima and then minimum value. Let us discuss me again the process in brief. Whenever you have given a function, to find out its maxima and minima, step 1 is find out its first derivative, put it equals to 0. When you will put it equals to 0, you will get an equation. Solve this equation. You will get some values of this equation. So these values of the equation is called stationary points. And you should remember, these stationary points will give you the point of maxima or point of minima. Now, after that, we will find out the second derivative of the given function and put any value of x, means any stationary point in the second derivative. If second derivative is coming out to be negative, then that stationary point is a point of maxima. And if the second derivative is coming out to be positive, then that point is known as the point of minima. So this is how you can find out the point of maxima as well as point of minima. What is left? If you are putting the value of any stationary point in the second derivative, it becomes 0. Then it shows that we cannot say anything about maxima or minima. Then we will calculate the third derivative, that is d3y over dx cube, and put that stationary value in the third derivative. If it is not equals to 0, then it shows that stationary point is neither point of maxima nor point of minima, as we did in this case. Anyhow, if the third derivative also becomes 0 for any stationary value, then again we say that we can't say anything about maxima and minima, and we will move for the fourth derivative. And the process for finding out the maxima and minima in the fourth derivative is verbatim as we did in case of second derivative. Which means, if the fourth derivative is negative for any stationary value, then that point is a point of maxima. And if fourth derivative is positive for any stationary value, then that point is a point of minima. So I think this is all a brief idea of the method how we can find out the maxima and maximum value and the minima and minimum value of any function. Let us take another example. Find the maximum value of the function log x upon x, right? So let y is equals to log x upon x. This is a logarithmic function, right? So what is the condition for the maxima and minima? First find out its first derivative, that is dy over dx. So we have calculated dy over dx here, and you know the function is containing numerator and denominator. So we will use the quotient rule to find out its derivative. And its derivative using the quotient rule is coming out to be what? Dy over dx is coming out to be 1 minus log x divided by x squared, right? And what is the condition for getting the stationary points? Dy over dx should be equals to 0. So see, 1 minus log x divided by x square, this is equals to 0. This implies what? 1 minus log x is equals to 0. This means log x is equals to 1, right? Log x is equals to 1. So which value of log we will get 1? So see, this can be written as log x is equals to log e. Log e is 1. So from here we get x is equals to e. So e is a stationary point. That is what we have achieved here. X is equals to e, right? So once we have achieved our stationary point, you know what is left? Find out the second derivative. For what? Dx is 1 minus log x divided by x square, right? Find out second derivative dy over dx square. Now again use the quotient rule to find out its derivative. This is dr square of this is x power 4, right? Dr x square into derivative of 1 minus log x is what? Derivative of 1 is 0 and derivative of minus log x is 1 upon x minus 1 minus log x into derivative of x square is 2x. We are getting the same thing here. See, x and x will cancel out, simplify it. You will get as minus 3 plus 2 log x divided by x cube. This is your second derivative, right? Now put x is equals to e in the second derivative. Now see what will happen, whether it is coming out to be positive or negative. See, d2y over dx2 at x is equals to e. See, this is equals to minus 3 plus 2 log e. Put x is equals to e divided by e power 3. And this is what log e is, you know, log e is 1. So this is minus 3 plus 2 divided by e3. What is left? Minus 1 upon e3. And this is negative, less than 0. Therefore, the function has maxima at a point x is equals to e. And to find out the maximum value, what we will do? Put x is equals to e in the given function. This is our function. So put x is equals to e means log e divided by e. And log e is 1. What is left? 1 upon e. So this is how we can find out the maximum value or minimum value of any function. So students, we should stop it here and we will continue in the subsequent text in the next lecture. Okay.